Let's take a look at an attack on a model using an adversarial example which uses the fast gradient sine method, which was described by Goodfellow and others in a kind of a landmark paper. So, what is an adversarial example? Adversarial examples are specialized inputs created with the purpose of confusing a neural network, resulting in the misclassification of a given input. These notorious inputs are indistinguishable to the human eye, but cause the model to fail to identify the contents of the image. There are several types of such attacks, however. Here, the focus is on the fast gradient sine method attack, which is a white box attack whose goal is to ensure misclassification. A white box attack is where the attacker has complete access to the model being attacked. One of the most famous examples of an adversarial image is shown here, and it's taken from that paper. We have a panda on the left that the model predicts with fairly high confidence. Some noise is added, which is fairly, opaque to a human. And the result is that the model now thinks that that panda is a gibbon with a very high confidence. So I'm not going to go into the details of the attack method. They're here, and this example is available in the references. You can go through it yourself. But what we will do is just walk through this example and show really how easy this kind of attack is. So we're running in a Colab here. We'll start by doing some imports of TensorFlow and Matplotlib. And then we'll load a pre-trained MobileNet v2 and the ImageNet class names. So this will take a second. There we go. And then we have this helper function here to do pre-processing. And then we'll take a look at the original image, which in this case is a Labrador Retriever. So we're going to download that data. And now let's look at the image. We'll do a plot here. And there it is, a Labrador Retriever. Okay. So we'll create an adversarial image using the fast gradient sine method. And there actually is the code that we'll use. You can see it's very simple. And we can visualize the perturbations that that method makes to give you an idea. So looking at that, most people wouldn't expect it to have really any change in the model based on applying that. But as we'll see, it does. So one of the things we do is we're going to try different values for epsilon, which is one of the parameters of the method. And we'll see how different values of epsilon have different predictions that the model makes. So we have a helper method there to display the image. And then here's some different values of epsilon and the resulting model prediction. So there's our original Labrador Retriever. Confidence is, this is actually, with the input. And then with epsilon 0.01, it now thinks it's a Saluki, which is a thin dog. And then a little higher value of epsilon, it thinks it's a Weimaraner. And again, a little bit higher than that, it still thinks it's a Weimaraner with a little more confidence. All right. So that's one very simple method of doing an adversarial attack that can fool the model into making an incorrect prediction based on image data.